Alright guys, welcome to Thursday. Here we go with the last set of notes for a really, really long time. So hopefully if you've gotten none of the notes from Tuesday and Wednesday, if you were absent either one of those days, at some point during class, grab a set of the notes from the wall over there. If you don't know where to find the notes, ask someone who's been in the class. They can help you find it because we've done a lot of pages in our notes packet, and hopefully you've been staying caught up. Today we're going to start on page 11. And we're going to cover real quickly groundwater. So Tuesday we did runoff, Wednesday we did streams and meanders, and Thursday we're going to do groundwater. So let's get right to it. The pictures from the picture of the day is from last year. It's just a cool picture of caterpillars that look like snakes. That's all it is. It was nothing more than to make you go, what? They kind of all look a little bit creepy. I like this one down here because it reminds me of a Ninja Turtle. I think that's awesome. So we're going to do some brief notes on groundwater, a couple pages in our notes. You'll have another page to work on with a friend, and it'll be a Quizmo at the end of the day. I'm sorry, at the end of class. Downside of the Quizmo, you only get one try on this Quizmo. So it's a quiz grade using gizmos, but for those of you who just guess your way through it and never actually open up the gizmo, this is not going to be the day that's going to end well for you. So you only get one try on this one. Okay, so we're in our notes on page 11, and today we're going to cover the vocabulary and the process of groundwater. So first thing, you've seen this term before. So there on page 11 you have a number 1. It says, where is water stored? And then you see a little box that says pore spaces. Define pore spaces. Those are the small openings between ground materials. So pore spaces were one of the factors of runoff from Tuesday. So if you remember from Tuesday, we listed 4 factors of runoff. It was pore spaces and slope and vegetation and I think precipitation, so like the actual rate of precipitation. Pore spaces drastically determines how much water can become groundwater. And then you have 2 little boxes that say amount of water depends on. Well, here it is. Number 1, the amount of water in a pore is going to depend on the size of the particles. And number 2, the variety of particles. Similar to Tuesday. If you have all the same sizes, there's going to be more particles available. There's going to be more space in between them. If you have a mixture of sizes, like outside here at school, if you scoop up the ground, there is a mixture of sizes, sand and gravel and silt. And so there's like no pore spaces. And so the second it starts raining at Boulder Creek, it starts collecting runoff and puddles all over the place because the ground doesn't have any room for the water. People always get confused. They're always like, but wait, Miss Price, it's the desert. Isn't the ground really dry and can absorb water? And no, it has nothing to do with it. It has to do with what kind of sediments are actually in the ground. So you've got some questions here. I want to give you a second to answer it. So the first one, it says, which do you think has the largest pore spaces? So look at these 3 pictures, A, B, and C, and write a letter in that box. Which letter do you think has the largest pore spaces? And then in the second box, how is B different from A? I sort of already gave you the answer. So for the first one, the one with the largest pore spaces is A. You can tell they're all very large sized particles with a ton of space in between them. B is different from A because it's a variety of sizes. So it has a mixture, or mixture is another word, variety / mixture of sizes of sediments. So there's basically no pore spaces in B. This B is exactly what is outside. This is what the ground is like outside, letter B. There is no room for anything to penetrate the ground very fast anyways because it's all filled up. There's no air in here. No air, no pore spaces. Flip your notes over to page 12. So let's say there are pore spaces, even though there's not here, but in some places there are. And the water gets into the ground. So it starts to rain, it rains. There's lots of room in the ground, there's lots of air, lots of pore spaces, and it gets in. There are 2 big areas you've got to know the difference between. It's the zone of saturation, so that's the definition at the top of your page on page 11. I'm sorry, page 12. Page 12. It's called the zone of saturation. This is the part of the ground that is saturated with water. It's saturated. The water fills all of the pores. Write that for your definition on page 12. Water fills all of the pores of a material. That's the definition of the zone of saturation. Then letter B is the water table. The water table is the upper boundary of that zone. So wherever all that water is, ooh, here it is. Here's the good picture. I knew it was on here. So this is the zone of saturation. This is where all of the water has accumulated. That very top border, so the border between the zone of saturation and the zone above it is called the water table. Those of you that live in New River or Desert Hills, you might have a well, and the location of the water table is very important to you. Maybe not to you, but to your family who takes care of the well. You want to know where the water table is. You want to know if your well is low enough. That's that top boundary. Now, when I was in school, this blew my mind, that groundwater moves. I always had the idea in my head that groundwater was kind of stagnant, that it just stayed in the same spot and we pulled it out and then rain would fill it back up. But it actually flows. So groundwater flows due to gravity. So going downhill, any sort of change in slope will actually pull water through the sediment, and it flows. It moves around. It moves around in the ground, in other words. Some other factors that determine the level of the water table, so how deep it is. So these are some things for those of you with wells. This is very applicable. There's probably at least 5 or 6 of you in here that have a well. The amount of precipitation has a lot to do with your well. Seasonal conditions, obviously the water table is going to drop in the summer because of the heat, and that kind of goes along with weather conditions. This is a great time of year for wells because we normally get, this is when we get our rain from the cold fronts coming down from Canada, and we'll get to that when we do weather, but we normally get a little bit of rain this time of year, and that gives our wells a chance to, the water table a chance to rise up a little bit. So remember, this is the saturated zone, and the water is actually flowing, and it would be flowing this way. So that's just a picture showing how there's a zone of saturation. Here's another picture showing how wells can cause some different shapes in the water. Depending on how deep your neighbor's well, that could easily change the water table. This is down for letter E, or is it E? Yeah, it's letter E. On page 12, letter E, groundwater movement. This is what permeability is. This will be a big part of what we do next week. So the tendency of a material to let water pass through it. This will also be on the gizmo today. So the more permeable something is, that means it's easy to pass through. So something like gravel. Gravel has a great permeability, a very high permeability. It's easy for water to flow through gravel. It is not easy for water to flow through sand. It can do it, it'll go through, but it takes a long time. The other word, letter E, number 2 on page 12, says what is an aquifer? An aquifer is where the permeable layer is saturated. So for those of you with wells, you're probably tapped into an aquifer. It is an area of water that has a material that is saturated, and it's surrounded by materials that you can't penetrate very easily, that it has low permeability. So aquifers are where we've kind of, Mother Nature in a way has trapped the water. These are your definitions for number 1 and number 2 on page 12. This is at the bottom of page 12, so I'll just be quiet while you write it down. All of these factors determine how well water in an aquifer can flow. So take a minute or two and write these down. The slope of the table, the permeability of the material, and then the occurrence of springs. These are going on letter F on page 12. When you finish, flip to page 13. It's our last note page for the week. The slope of the water table can change as water flows. The permeability of the material will affect the ability for the water to flow. And obviously, when natural springs emerge, that's because the ground's saturated and the water has nowhere to go. And so springs are actually water coming up from groundwater, which is kind of cool to think about. It's like the earth is bursting with water. Natural springs come from the ground. Okay, page 13. Before we get to that, this is kind of just a depressing picture, that because water is moving, sometimes it flows, in a sense, through something you don't want it to flow through. Humans are really good at polluting. We're really, really good at polluting. It's amazing how good we are at pouring in gunk into water. So keep in mind, whenever you pour in gunk into water, it enters the water cycle. And this could become groundwater. This pollution could work its way to your well. There's areas of the world, a large portion of the world, most of the world actually, doesn't have clean drinking water because so many other pollutants have been dropped into the water. So this is something, if you sign up for environmental science, you'll spend a lot of time examining the different types of pollutants and how they affect us. It's really depressing, the struggles that people have finding clean drinking water. So on page 13, we're going to quickly go over wells and something called subsidence. Obviously, wells are when you drill a hole into the ground. Humans dig a hole until we get to an aquifer. This has been a problem. Maybe you've seen it in the news or the In-N-Out magazine. There was some overpumping in Desert Hills that caused what's known as a cone of depression. So the water table actually dipped down, causing some wells to go dry. So people didn't have any drinking water. This picture's in your notes, so it shows a nice, happy, healthy water table that's being replenished by rainwater and flowing nicely through the aquifer. And then we've got some jerk. This house in the middle here is a jerk. They pumped more than they were allowed to pump that month, causing what's known as a cone of depression, and that sunk down the water table. So one person not following the rules ruined it for the neighborhood. Now these guys are thirsty, and everybody's mad. A big threat to water supply around the world is overuse. So if you use water faster than it can replenish, then you're going to run out of it. So most places that have a well, they're really regulated of how many gallons they can take away per month. Now, corporations are really good at taking more than their share. Subsidence is something that you might know as a sinkhole. You see this a lot in Florida. Florida has a lot of groundwater. That groundwater moves around. Now just imagine you have a ton of groundwater and a bunch of it goes away really fast. So those pore spaces that were once filled up with water is now gone. And so this is a bad picture. Now it sinks in. So the sediment kind of collapses in on itself. So a bunch of air is created. This is a more realistic picture of a sinkhole. The water has moved, creating more pore spaces, and it actually, the ground actually sinks in. This is a depressing picture. There are a lot of aquifers in the United States that have been overpumped. This is an actual location of the ground. So in 1925, the ground used to be up here. But in agricultural areas of the country that pull excessive amounts of water from aquifers, the actual ground sinks as we deplete the water. So since 1977, honestly, in the 80s and 90s, there was a lot more legislation put into place as to how much water could be pumped, because this is what happens when you overpump. This is what happens when groundwater moves on its own. So this problem over here of this major sinking was caused by people. This problem over here with the road sinking in, that was just caused by groundwater movement. That's called subsidence. Obviously, like I already mentioned, groundwater can get polluted easily. Once you incorporate any sort of pollution into an aquifer, you're kind of screwed, because that's going to spread throughout the ground and it's going to continue to contaminate. So once one portion is contaminated, the water cycle is a beast and everything else will get contaminated as well. There's a lot of ways that we pollute the ground, and like I said, if you sign up for environmental science, you will spend an excessive amount of time next year studying all the ways that humans pollute the world. This is showing basically a contamination because someone was depositing some sort of a waste. So maybe that was a corporation, maybe it was a person, maybe it was a painter, and they were dumping all their paint into the ground. And those chemicals then got into the groundwater, and that groundwater, like I said, it flows. Groundwater moves. It doesn't just stay in that one spot. It flows, and now we're going to have an issue with the water supply. So you've got to be conscientious of how you're disposing of waste. Farms are the worst. Farms are really, really bad. They have a lot of waste from animal waste and machinery waste and just tons and tons of pesticide waste that gets into the groundwater. Landfills, a leak in the landfills, that's bad. Very bad. Radon gas is a natural, it's a natural gas that forms, and so that'll get you as well. So really what you have to know for this class is that groundwater pollution ruins it for everybody. This is somebody, let's pick on someone who lives in Desert Hills. They have a septic tank. By the way, if you don't know what a septic tank is, that's where all your poop water goes. You flush your toilet and it goes to your septic tank. Well, if that septic tank isn't working right and it busts, now all of that grossness is in the groundwater and it's going to go to your neighbor's house. They're going to drink it. So there are a lot of regulations that you have to follow through if you have wells and septic tanks. So on page 14, you'll find a picture showing a little town here. Notice these layers of clay. Clay is impermeable. Sorry. That was the bell, I'm sorry. Clay is impermeable. Water cannot penetrate clay. It has no pore spaces. The word there is impermeable. So when you're answering your questions, please keep that in mind, that the clay layers in this little town you cannot penetrate them. That's going to make a big difference as to your understanding of this picture. So just like the pictures from yesterday, you have 7 questions to answer on page 14. This is going to be checked on Friday. So if you want to do it right now with a friend, great. If you want to say, no, I'm going to do it later during math class because I want to get my assignment done, that's fine. But pages 9, 10, and 14, I'm going to look at tomorrow in class. And so please, 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 please have them done. Your assignment for today is a Quizmo. So remember, you log into Gizmo. That's explorelearning.com. You log into Gizmo. There should be one there called Porosity. And sorry again. I kept meaning to time that better, but oh well, I talked too long on this one. You're going to use the Gizmo to answer the questions, but you only get one try. So if you screw it up and you only get one right, that's your grade. This is due at the end of class, and so you want to make sure that you focus and you do it. Sitting around doing nothing is not acceptable. You have the Gizmo to work on, so those questions you can find on Canvas. You also have pages 9, 10, and 14 to do for tomorrow. So Miss Baptist will be walking around. She'll make sure that you're getting something done. The Gizmo's due at the end of the day, and those pages are due tomorrow in class. That's it. I will see you tomorrow in class. Have an awesome rest of your day.